The area of a trapezium. The formula for the area of a trapezium is a half of A plus B times H. Now, let me just draw, well, attempt to draw a very quick trapezium. Oh, there we go, trapezoid. Okay, so there's a trapezium. That is A. That is B. And H, I'm pretty sure you've guessed, is the actual height of the trapezium. Okay, so there's your trapezium. So the formula actually has you find the average of A and B to give you an average width, and then you times that by the height. So it's kind of like finding the area of a rectangle. You don't need to know that, I don't know. I find it interesting, but I'm weird. Okay, so I'm going to pick an example that's very similar to the one in the project, alright? Now, they've said that a half, remember I'm writing a half as 0.5 because I'm doing it on a computer, of y plus 5. It doesn't need to be y, it could be a to match up with that. It's just a variable at the end of the day, something we're trying to find. 8 equals 64. Alright, so that means that one of the sides of the trapezium is 5, the height of it is 8, the area is 64, and we're trying to find the other missing side. Now, in the project, it actually does the first step for you, because this is a bracket that's being times by two things at once. And they do it like this. They times everything by a half for you. So pretend that 8 isn't there for a minute. Let me just move it off to the side, or we'll bring it like later. They've expanded this bracket. They've done a half times y to give you a half y. And they, in the example, I think it's 6, so they do like half times 6 to give you 3. But over here, we're going to do a half times 5, which is 2.5, because that's half of 5, right? Let me just bring this back before I forget. So, the contents of that bracket have been multiplied by a half, and that gives us that. We've still got the 8 equals 64 bit to worry about now, though, okay? So now we multiply everything in the bracket by 8, because that bracket is being times by 8. So we multiply everything inside it by 8. So a half times 8 is 4, so 4 y's, and 2.5 times 8 is 10. Yeah? Wait, hang on a minute. No, it's not. What am I on about? No, it's not. Sorry about that. It's been a long day. 20. Sorry, guys. And that's equal to 64. Okay, so 4y plus 20 equals 64. This is starting to look a lot more approachable now, something that we're used to. I'm going to go through this quickly, not too quickly, but quickly, because if you're up to this point, it means you've been solving some equations already, so you know what to do. So we're going to take away 20 from both sides to give us 4y equals 44, divide by 4 to give y equals 11. So the missing side of trapezium in this case was 11. Okay, now I'm pretty sure it's not going to hurt anybody if I work through the examples of the project with you, alright? Because the only problem is I'm not 100% on what the numbers are because I haven't got them with me. That was a 6, definitely. That was a 10. I think this was 80? Let's see what happens. Couldn't hurt to work through another one. So the project does the first step for you and times everything by a half. So you have a half y plus a half times 6, which is 3. 10 equals 80. I'm pretty sure these were the numbers actually, because I think I remember how it works out. Okay, now we times everything inside that bracket by 10. So a half times 10 is 5, so there's 5 y's, because it's that half times that 10, yeah? Next we do 3 times 10, which is 30, and that's equal to 80. Now we can work through things just like we've done before. Take away 30 from both sides, so give 5y equals 50, then divide by 5 to give y equals 10. Don't like it when it auto capitalizes. There you go. So, cheated a bit for you. That's how you do the one on the project. Good luck.